Hi everyone, today we're going to be solving rational equations. Your essential question for this set of notes: what should you always remember to check once you have solved the equation? We're going to be referencing that towards the end of this set of notes, so keep that in mind. So how to solve rational equations? Well, we have been solving rational expressions before. We've been adding, subtracting, multiplying, and dividing. We haven't seen an equation yet. We haven't seen an equal sign yet. So the steps on how to do that: our first step, multiply each side of the equation by the LCD. LCD stands for least common denominator. Your second thing, you're going to solve the resulting equation. And then your third thing, always remember to check your solutions. And why do we always want to remember to check our solutions? Why do I keep having you guys do that? Well, if the number, your solution that you end up getting, if we plug that value back into the denominator of our fraction and it makes it 0, then that makes it a false statement. We can't be dividing by 0. That's not allowed. So that's why you are checking your solutions to make sure that is a real solution and it won't make our denominator equal 0. Okay, so go ahead, this is going to be the directions for all of our examples, so go ahead and write this down one time and then we'll just start writing down the examples. So solve each equation and check all solutions. Our first example, we have 7 divided by x minus 6 equals 4 divided by x this time. So we're just going to, it's the easiest to actually find your LCD, so your LCD is going to be, let's actually put it over here on the side, my least common denominator. So I just think it's easier just to multiply by both the denominator values. So I'm going to multiply this fraction. Let me reverse my parentheses here. I'm going to multiply it by x minus 6 times x out there. And this side as well, x times x minus 6 out here. So I just multiplied my entire fraction. I multiplied the left side as well as the right side of my equation by the LCD. Now, the next thing it says to solve the resulting equation. So we want to see what we have resulting left. I can see that my x minus 6 and my x minus 6 are going to cancel each other out, which is nice because we have an equation and we don't want to be left in tons of fractions. So now all I have in my numerator is actually 7 times x, which is 7x. Well, here my x and my x get to cancel out as well. So now I'm left with a 4 times x minus 6 in my numerator. So these were our fraction busters. Remember, we busted out of those fractions and we no longer had a denominator left over. So now this is us solving our remaining equation. So we are going to go ahead and actually distribute this 4 to the x as well as that 4 to the negative 6. Then we are still left with our 7x, and now we need to go ahead and actually solve for x and get it by itself. So we have subtracting 4x from both sides. Then we are left with 3x equals a negative 24, and we're going to go ahead and divide by 3 on both sides, and we are left with x equals a negative 8. Okay. We aren't done just yet. We just want to make sure that if we plug in the negative 8 into like our original equation here, so if I were to plug in x minus 6 and I plug in that negative 8 right there, well, negative 8 minus 6 definitely does not equal 0. So we actually do have x equal negative 8 as our actual solution. For our next example, we have r divided by r minus 1 equals 4 divided by r. Again, let's write our LCD over here so we know what we are actually going to be multiplying by. So I like to do r times r minus 1. Then I know exactly what to actually multiply both sides by. So if I multiply this side by r times r minus 1, as well as this side, then I can actually get rid of my fractions and actually make my problem a lot easier to solve for. So these are going to cancel that side out. This r and this r are going to also cancel that out. So now I have an r times an r on this side, which is r squared. And then I'm going to distribute that 4 to this r. So 4 times r is 4r. I'm also going to distribute that 4 to the negative 1, which is a negative 4. Okay, so now I'm going to be going through and solving my equation here. We're kind of going way back to our last unit, where we have a squared term right here, a quadratic, so we can't just simply solve for our x like we did in the last problem, our linear problem. So we need to actually get one side to equal 0. Since my squared term is on that left side, I want to remain that and keep it positive. So I'm going to subtract 4r and add 4 from both sides because I want to get one side to equal 0. So now I am left with r squared minus 4r plus 4. And now I have a side that's equaling 0. Okay, so now once my one side equals 0, I now have to factor because I know I'm going to have two possible zeros or two possible roots that are going to allow me to equal 0 here. So I have a coefficient of 1 here, so I know I get to write my factors out like this already. And then we have r's here, and now I'm trying to figure out what's multiplied to 4 but adds to negative 4. So I know that if I have a negative times a negative, I will get positive, and then a negative plus a negative will get me a negative 4. So r minus 2 times r minus 2. So from here on out, this is where you write your r minus 2 equals 0, because we need to solve our values. So r minus 2 equals 0. Let me rewrite that. Minus 2 equals 0. Well, luckily it happens to be both the same thing, so we do get our r equaling 2. So we just want to double check that if we were to plug in 2 into our original formula here, that we wouldn't get 2 on the, or a 0 on the denominator. So 2 minus 1 is 1, perfect, and then 2 is just 2, so we don't have a 0 anywhere on our denominator, so our r is equal to 2. And that is our final solution for this example. Our next example, we're just getting a little bit harder as we go. Again, my LCD, we're just writing this so I know what to be multiplying by. So 2 times x plus 4. And now I get to actually multiply this side by 2 times x plus 4, and this side by 2 times x plus 4. Now we're going to go ahead and divide out whatever can. So now I'm left with an x plus 4 up here times a 2x minus 3 equals, and then my x plus 4 does divide out, and then 2 times 3 is 6. Okay, so now I'm going to go ahead and distribute all this. So x times 2x is a 2x squared. X times a negative 3 is a negative 3x. 4 times 2x is an 8x. And 4 times a negative 3 is a negative 12. That is all equal to 6. Now I'm going to go ahead and combine like terms. The only terms I can combine are these right here. So now I have a 2x squared plus 5x minus 12 equals 6. Okay, awesome. Well, guess what? I have another quadratic, so I have to get one side to equal 0. Well, this only has a 6 on it, so I'm going to go ahead and subtract 6 from there. So now I get 2x squared plus 5x minus 18 this time equals to 0. So now I'm trying to figure out, I'm going to use my diamond method over here. So I'm going to try and figure out what two numbers you have to do 2 times negative 18, which is your negative 36, but adds to 5. So if I go through and do this, I am checking to see what two numbers multiply to negative 36 but add to 5. And those two values are 9 and 4. So I need to figure out which one I want to be positive. Well, I want the higher ones to be positive and my lower ones to be negative, so I can, when I multiply them, I get that negative value. Okay, so now I'm going to go ahead and do my factor by grouping. So I set it up, bring down your a term, so 2x squared, write my new b terms. So this could be a plus 9x minus 4x minus 18. Bring that 18 down, equals 0. Okay, so now I need to find my GCF for those two terms. So I am just given an x, and now I have a 2x plus 9. And then my GCF here is a negative 2, and I'm left with an x plus 9. Sorry, 2x plus 9. Okay, so I did actually do my factor by grouping correctly. So my factors are, it's right over here, so I have a 2x plus 9 times my GCFs now, so x minus 2. Okay, and that all equals 0. So I'm going to go ahead and make some room here, you guys, just so, but don't, make sure you're writing this whole thing down. So I'm going through and I'm making sure that the values that I have here, I'm just going to erase everything so we can see. So I have my 2x plus 9, and then I multiply that by x minus 2 equals 0. So now we're at the point where I'm setting each of my factors equal to 0, and I'm going to be solving for x to see what those values are going to be for my solutions. So on this one I'm going to subtract 9 from both sides, and I get 2x equals a negative 9. And then I'm going to go ahead and divide by 2, and I can't simplify that fraction any further, so I'm just going to leave it as negative 9 halves. This one I just have to add 2 to both sides, and I get x equals 2. So I just want to double check that these values right here, if I plug them into my denominator, that they're not going to get me to equal 0. I know that 2 plus 4 is 6. I also know that negative 9 halves, if I were trying to add that, it's definitely not going to get me anywhere to 0. So we are good. Those are our two final solutions. Okay, let's add on a little bit more. So here we have our two values right here. We have a negative sign in addition to our equal sign. So we want to be careful with this. We're going to still use the same process of using our least common denominator. In this case, we want to check our numbers. So does 3 go into 6? Yes, it does. Awesome. So our LCD of our numbers is going to be 6. Then we also have that letter, that variable of n in there. So 6n is actually my least common denominator that I want to be multiplying my entire fraction thing by. This time we have 3 different fractions we're going to be multiplying it by. So let's multiply this fraction by 6n, this fraction by 6n, and this fraction by 6n. So now I'm going to go through and I'm going to make sure I can simplify these out. So 3 goes into 6 2 times. So now I have a 2n being multiplied by 4. Let's go through and simplify everything first. On this fraction my n's cancel out and I'm left with the 6 times 7. And this, my 6's cancel out, I'm left with just my n. So it's really nice because it helps us eliminate what we were actually supposed to multiply by. So now I have a 2n times 4. So I have 8n here, and then 6 times 7, and don't forget it's a negative, so you have a negative 42, equals 1 times n, which is just n. And now we get to go through and actually just solve our equation for n again. So I see I have n's on both sides. I'm going to go ahead and subtract n from this side because I want to remain positive. You guys totally don't have to. And then I still get 0, and then I'm going to add 42. It's okay to get 0, you guys, on a side of an equation. You're not done yet. And it's still okay even if you did. So 42, divide both sides by 7. So now we can get that n by itself and actually get n equals 6. Okay, so we just need to double check again that this n can go into the denominator of our fractions at any 3 of our fractions, and it won't get us 0. The only n that we have to actually plug that into is right there, and our n equals 6. Therefore, our denominator does not equal 0. So n equals 6 is our final solution. Okay, and then we have x plus 6 divided by x plus 3 equals 2. Well, that's not a fraction. How do we make it a fraction? We put it over 1. Minus 5x plus 12 divided by x plus 3. So when we actually look for our common denominator here, it's nice that we only have a 1, and our LCD is actually only going to be x plus 3 here. So now I'm going to multiply every single fraction by x plus 3. I have 3 of them here, so make sure you actually write this 3 times so you can see what eliminates. Awesome, my x plus 3's eliminate there, so I have x plus 6 here. And then I have nothing that eliminates x. This 1 does not help me eliminate anything, however, it does just give me x plus 3. So I'm going to end up distributing this 2 to the x as well as to the 3. So let's go ahead and do that now. So I have 2x, and then 2 times 3 is 6, plus 6. And then here we also see that those divide out, and then I'm left with a negative 5x plus 12. Okay, so now, oh, and be careful because this negative, put parentheses around this, so that negative gets distributed to both the 5x as well as the 12. So just be careful and watch out for that, you guys. Okay, so let's go ahead and combine like terms on this right side. We get x plus 6 equals, I have a negative 5x plus 2x, so I have a negative 3x, and then I have a negative 12 and a positive 6, so this is a negative 6. So negative 3x minus 6, x plus 6 on the left side. Okay, so let's go ahead and try and get an x by itself. I see that I already have negatives here, so let's add them. So this is going to make me have 4x here. I'm going to go ahead, these cancel out. I'm going to do 2 steps in 1. If this is too fast for you, slow the video down. It's okay. You're subtracting 6 from both sides to get those out. Equals minus 12. Now we are going to divide by 4, and I get x equals a negative 3. Okay, so now our last step is just to go back to our original equation to check and see if our solution actually is a solution. Or does it make our denominator equal 0? Well, guess what? When I plug in negative 3 for that x, negative 3 plus 3 is equal to 0. So this negative 3 is actually not a solution. It will not work because it just made our denominator go to equal 0. Okay, so just to recap you guys of what we actually learned, I just want to go back on your essential question. What should you always remember to check once you have solved the equation? So go back, think about that. You will be getting asked about it to answer the question. So we went through and we solved simpler rational equations where we are still using the LCD to actually eliminate our fractions and make our equations a lot more simple to actually solve. Just be careful because they get a little bit harder when you add and subtract those values in there, but you're just adding more fractions. You're still using the same process of multiplying all the fractions by the LCD, and you guys should be good to go. Again, if you guys have more questions, please go ahead and re-watch these videos. You guys, they're here for you to slow down, speed up, anything like that. So go ahead and take the time to do that now. Thanks.